in the quite large picture here on the right. I'm an enterprise security architect at Splinter. And what we do at Splinter is we work with a variety of clients to try to provide a more holistic approach to security. We call it an enterprise architectural approach. So we're not just trying to look at individual solutions, but really how do these solutions fit into the broader landscape. This also gives us sort of a privileged position with a lot of different projects where we can really start using threat modeling really early in the development pipeline, or even at places embedding into like different parts of the organization. Now, our talk, Layered Threat Modeling, is kind of the culmination of a lot of work we've been doing in the past 2 years, trying to build that bridge between enterprise architecture on the one hand, cybersecurity on the other, and then also threat modeling as a principle. So let's just start diving right in. On the right here, you can see something you're probably, most of you are all kind of familiar with, is a more traditional data flow diagram, kind of also a rather big one. And we kind of call this solution threat modeling. We take an individual system or specific solution and we identify components, connections between these components, and ideally also quite clear trust boundaries. Then using all this input, we're going to try to leverage certain techniques such as Stride or Linden to identify threats. And very often, we're going to be embedding this kind of solution threat modeling in our design phase of our software development lifecycle. Of course, sometimes this can bleed into our build phase, but ideally we want to shift left so that we can find threats as early as possible, which then eventually lead to risks. So ideally, we want to do it in our design phase. There's a variety of notations that you can use to really leverage threat modeling, such as data flow diagrams, UML diagrams. There's just a whole heap of literature that you can kind of build upon. Now, what you might not all be familiar with is something called architectural threat modeling. The idea with architectural threat modeling is that we're going to try to do threat modeling before we're even jumping into our software development lifecycle. Think about it as similar to what Adam talked about earlier. What if you have more higher level abstract questions such as we need a CRM system, an HR system, we're migrating to microservices. With these higher level concepts, we can already start doing threat modeling while focusing on the concepts, not the solutions. Now, I'm going to make it a little bit more practical. We work a lot with business analysts, product owners, embedded in the software development lifecycle at a variety of different clients. We often run into the following scenario. Let's say we have a business analyst and she gets tasked with developing some kind of new web store, an online web store. Now, she wants to do this in a secure fashion. So she'll come to us or someone else, a security architect, and ask us, how can we make a secure online web shop? Now, we as security architects, we want to get started with threat modeling. But it's kind of difficult to do that starting with just that abstract concept, that abstract question. So typically, the business analyst or the product owner, application owner, will then retreat and perhaps go to an enterprise architect. Together with the enterprise architect, they'll start drafting an initial view, an architectural view of what the application will kind of look like. Now again, there's no specific technologies, there's no real clear connections and boundaries, so nothing that allows us to develop a nice, clean data flow diagram. So again, as security architects, very often we have to kind of give the disappointing news that we can't do threat modeling at this point just yet. Only after they go to a lead developer or technical architect and really start getting more of that concrete architecture, only then can we typically start with that solution threat modeling. That's not ideal, and that's kind of what architectural threat modeling tries to solve. So, solution threat modeling makes us shift left earlier into our software development lifecycle. But architectural threat modeling kind of makes us shift up a layer. It's kind of also the main thesis of our talk here is we argue that threat modeling is not just an activity on the solution layer with developers, with technical experts, but is also something that should be replicated at the architectural layer. Now, all of this isn't new, and it's actually confirmed by a whole lot of different frameworks, such as TOGAF, Zachman, and SUBSA. SUBSA is actually quite old. It's from the early 2000s. Also, both Zachman and SUBSA build up off of TOGAF. SUBSA is sort of a framework that encapsulates a lot of the first two, but more in an information security context. And when we were looking at SUBSA, reading it, interacting with it the last few years, we noticed that there was a very clear kind of layering. Right? Different security activities occur at different layers. And certain activities are also replicated across layers, but then on different kind of attributes. And the same is confirmed in TOGAF and Zachman. Right? Oftentimes, there's this kind of idea of an architectural layer, or an architecture continuum, this is TOGAF, as well as a solutions layer, or a solutions continuum. And these are different, but closely related and quite similar in a lot of ways. On the architecture layer, we'll find concepts such as just a generic rocket. BIAN is a sort of international enterprise architecture framework for modeling a bank, so any kind of activities involved in a bank, the kind of capabilities they have, all kind of represented in an architectural fashion. When we take this idea of a rocket, we make it more concrete, becomes something like the Starship mega rocket. Becomes more concrete, more implementation based. There's also examples of architecture at this solution layer, such as Santander's solution architecture. But now, how can we start doing threat modeling on this architectural layer? Is there any way we can do it in an efficient, useful manner? That's the next part of our demonstration or our talk. We want to start off with the idea of threat modeling a pattern. Now, what is a pattern? Well, we've got a small TOGAF definition here. A pattern is a template describing a generic solution to a problem that occurs frequently in a given context. So the idea is we want to kind of have a solution at the ready that we know is a solution to a lot of different kind of problems. We've thought about it ahead of time, and then we can efficiently plug it in whenever we need it. Now, patterns as an idea are also replicated across layers. At the architectural layer, patterns define conceptual relationships between various concepts. So it's a conceptual solution you can reuse a lot of times between mostly higher level abstract concepts. Then on the solutions layer, that solution pattern will define the system itself. Right? So a system that can solve the problem that we've identified. And it does that by realizing the architectural pattern that we found in the architectural layer with several concrete components. Now, we're going to show that using ArchiMate. ArchiMate is an enterprise architecture modeling language. It's similar to UML, but it has this idea of layering just baked in, something that's quite common in Belgium and the Netherlands. Here at the architectural layer, this is kind of what an architectural pattern looks like. It's just a simple REST API system. So traditionally, almost every single time that you develop some kind of REST API, you'll have a user which wants to send a request to a REST API interface. Ideally, this request will have to pass through a web application firewall. It's then forwarded towards the application logic itself, which makes use of a database to get data. So this is kind of a generic solution to a problem that occurs frequently. At the solutions layer, this pattern changes a bit, right? So we still have the user, which is now a concrete customer. And so this is a concrete solution. We have an online web shop, which is a concrete implementation of a REST API, right? But we're still a pattern. And now, that firewall, at this point, doesn't just need to be a generic web application firewall. We now know it's going to be a perimeter firewall, even using perhaps a specific technology, such as F5. Right? The API, the REST API, now becomes specifically the web shop API. Our application logic suddenly gets split into two different concepts. On the one hand, we have an online web shop, and then on the other, we still have some legacy functionality we leverage. And that database that we saw earlier is not only separated by its own firewall, but also is now split up into two different kind of specific databases, one of which is MySQL. Now, this pattern is a lot easier to implement and is a lot easier to leverage for technical architects or the business analyst we talked about earlier because of the fact that they started with the architectural pattern. Now, the same applies for a threat modeling exercise. We can threat model this architectural pattern. Now, we're going to be using KPEC here. So KPEC is kind of a library of common attack patterns. They're not exactly threats, but they're very closely related. And we're going to be using KPEC threats to just chart on our architectural pattern. So between our interface and our logic, we'll always run a kind of risk to interception. The logic itself, because we make use of a user, will always be vulnerable to a kind of identity spoofing. Then also, because we make use of a database, we'll have some kind of threat towards command injection. Now then, on the solutions layer, right, so this is, again, think about the business analyst. She can get this solution, this pattern, before even getting started with actually developing the rest of the application. So she already has an idea of the kind of threats that will be existing in her online web shop because of the fact that she's going to be leveraging a REST API. So then it becomes a lot easier to threat model on the solutions layer pattern. The interception attack now becomes sniffing attacks, a specific kind of interception attacks. Because this online web shop pattern makes use of username password as authentication, it's not explicit, but it's kind of an assumption. We now know that that identity spoofing threat of earlier is actually password brute forcing. Because we have legacy functionality, we're also vulnerable to a malicious software update. And that command injection attack of earlier, well, we make use of MySQL, so it's a SQL injection. Note the difference between these two kind of threats. Right? So these architectural threats are more abstract. They're at a higher sort of abstraction layer. They're architectural. And these threats that we found in the solutions layer, actually I'm going to go back a little bit so you can look at it a bit more side by side. These in the solutions layer are more concrete. They're sort of implementing the threats that we found at that architectural layer. And again, we found that this was confirmed by a lot of the frameworks we were using. KPEC itself has a sort of abstraction trait. Now, it's not that clear. Laser pointer also isn't that clear. But KPEC has this idea of meta attack patterns as well as standard attack patterns. And these meta attack patterns are very much closely related to the idea of an architectural threat. Now, not always, it's not a perfect overlap, but it's very close. And then these standard threats or attack patterns oftentimes inherited a lot of the same properties. And that starts to also create a small distinction or significant distinction. Architectural threats, more abstract, more conceptual, tend to occur more at that architectural layer. And we can use something like KPEC meta attack patterns or other kind of threat catalogs such as BSI elementary threats. The solutions threats can use standard attack patterns, or we can use a lot of OWASP threat catalogs at that solutions layer, a lot of the knowledge that we've already built as an industry. Now, both can still use Stride because Stride is more of a conceptual approach to threat modeling. Also, typically, we'll find architectural threats through something we call an architectural risk assessment. Right? So assessing, for example, patterns, and the solutions threats using a solution threat model. Now, a final dimension I want to touch on before we actually reach the end is the fact how these architectural patterns also enable a new kind of dimension in terms of stakeholder management. For this entire exercise, we adopted the ArchiMate risk overlay, which is just sort of a built-in risk management layer on top of the ArchiMate modeling language. Now, ArchiMate is a modeling language oftentimes leveraged by enterprise architects, who typically were not involved in threat modeling exercises, because threat modeling was deeply embedded in the software development lifecycle, in that design phase. And oftentimes, enterprise architects, we saw that they weren't really just involved in those workshops. But by using tools that are common to them, that they use, we can now reach a new kind of stakeholder who also has a lot of insights into what can go wrong or how we can do threat modeling better. It also enables new dimensions in terms of how we communicate with, for example, management or do reporting. Because these architectural threats, the architectural patterns, we can also link them quite easily to control objectives. For example, identity spoofing, well, in our policy, our security policy, we might have a statement, our applications must be resistant to spoofing. Of course, seeing as both exercises exist at a similar conceptual layer, we can just combine these sort of almost on our threat model. And that way we can track, is our policy, are our policies, are our standards, are all these things, do they fit together nicely with all the other activities we're doing? And that's just another thing that replicating threat modeling at the architectural layer enables. Now we've reached the end of this talk, and I just kind of want to summarize. What's our main idea? Well, threat modeling can also be replicated at an architectural layer within businesses or within software development. We shouldn't just think of it as a one-off exercise or even a repeatable exercise that we do when developing a product, but we should think about it as a more holistic approach. We want to use more generic threats at that architectural layer, and there is somewhat of a distinction, somewhat of an inheritance between architectural threats and solutions threats. And finally, we can reuse a lot of notation, a lot of toolings, a lot of frameworks, methodology, knowledge that's been built up over the years and leverage that to do threat modeling at that architectural layer. This enables us to do a whole new kind of stakeholder management where we interact with enterprise architects, we embed threat modeling before we even start developing our products. We are able to communicate better with management, and we can start proving the efficacy of all of the efforts that we're taking. That was it. Thank you for your attention. And now, hopefully, we should still have quite some time for some Q&A.
Any questions? Thank you for the great talk. And since you mentioned ArchiMate, I did use ArchiMate tool briefly once. I didn't know that there's a risk layer. So is that the risk overlay thing is that you're actually using to help you generate the threat model, or is it still a manual exercise?
A lot of it is still a manual exercise. ArchiMate is kind of, as a standard, it includes this idea of overlays, which means that anyone can adapt the standard or can improve upon the standard, of course do this for more community outreach, to add new kind of concepts which might be useful in the various layers. And then one of the ones that they also describe actually in their official documentation is this enterprise risk management layer. And it's basically just an implementation or a specification is the right word of a lot of different ArchiMate components, but then for risk management. So it's a manual exercise in that we now have a lot more components, we can express new concepts, but we still, of course, have to manually identify these, of course, because we can make use of threat catalogs, we can use a lot of the other systems that we might use for threat modeling. Yeah.
Thank you for the talk, it's really good. I have one question though, on the note of using overlays and especially ArchiMate. In reality, some of the diagrams can get really, really hairy and complicated.
And if in some cases when we showcase this to, say, product owners or someone, or developers, they kind of get lost in it. It's like, what's going on? What I wonder is, do you then break down the output of what you've done into specific deliverables to talk to different stakeholders? How do you then translate what you've got here? Imagine whether it's a pattern or even if it's a solutions layer threat model that you've done in ArchiMate. Do you then have to translate that into specific deliverables to talk to different stakeholders?
In my opinion, one of the main deliverables you generate in threat modeling is a catalog of threats, right? So a few things. First of all, I'm not entirely sure that developers always need to use solution threat models in ArchiMate. That's just a useful thing. However, this more abstract view, right, with the architectural threats helps them, enables them to use, for example, data flow diagrams at that solutions layer. Now, again, I'm more convinced that a list of threats is a better output, and that then eventually leads to risks which can be reported to management. So I kind of see that as the concrete deliverable, but the less clear deliverable is the fact that you're able to talk with more people. You're able to get them thinking in the same direction, agreeing, and also you're making something that's a lot more manageable over a long period of time. It now makes sense where we got those risks from. If management asks us, hey, how come we suddenly got 5 new risks? We can just trace that back and show them these models on demand, not as a deliverable, not as a necessarily chunked up part, but when needed. Does that kind of answer the question? Okay. So,
you talked a bit about reusing notation. I'm curious, do you ever take the output from these architecture models and feed them into solutions models? The reason I ask, and the reason this occurred to me, a lot of the pushback I get from, say, standard development teams in doing a threat model is a lack of understanding at the higher architectural level, and occasionally I'll get feedback like, well, why don't we wait until we have better documentation or a better understanding of the architecture we depend on, and then we can threat model. So curious what your take on that is.
I think it's a bit of a difficult question because what makes it difficult is the practice, right? Of course, I can explain how it works, right? I can explain here we have these architectural patterns, and then if you give them to developers, they'll have a better idea. But I think that's where the human element, the craft element of threat modeling comes in. Is how I'm not sure there's a nice answer in the literature or in our methodologies to doing this perfectly. I think that's just a lot of time and improving bit by bit by bit by making these architectural patterns, these diagrams, these models more clear, like able to be understood better. I think that's what our main job actually is that's what we really bring to the table, is improving that, is making that useful. I'm not entirely sure that there's just a clean-cut answer. It's just a lot of time, a lot of talking, a lot of work, which isn't, flashy, but I think that's probably the most honest answer I can give.
So a practical question. The value of understanding and dialogue is great, and we covered it, but on a practical level, does each developer need to log into ArchiMate and understand what's going on, or do you export it to tools that they work on a day-to-day basis?
The main stakeholder we're trying to reach with architectural threat modeling isn't the developer, it's the enterprise architect. Is getting the product owners, product managers, business analysts, business people to sit down with enterprise architects and start thinking about threat modeling then, right? Because I think we've done a lot of good work in terms of threat modeling together with developers. I don't I don't think that developers should log into ArchiMate, but I do think that these kind of diagrams will help them do their work. Instead of them having to go to start from scratch, instead of them having to develop entirely new data flow diagrams or something, they have something to work off of. That's really the useful part. It makes something like Stride less vague, it becomes more concrete. There's a better chain of where we want to go. So that's kind of how I would answer it.
Got time for one more question.
Thank you. What you showed was taking a lot of like solution threat events into the application based on architectural decisions of how you would compose it. Have you had experience about taking enterprise risks like maintainability, how to connectivity things, and transforming these enterprise architecture threats into requirements then in the solution level?
I've thought about it, but I think it's tricky. Right? The main dimension I tried to focus on in this sort of talk was the idea of the patterns. Because in my opinion, the patterns, I'm trying to go back to the pattern slide, like this kind of makes it clear why you would want to do architectural threat modeling, but the kind of threats you're talking about are sort of the next step. Patterns are not the only way that you can leverage architectural threat modeling, not the only way that architectural threat modeling will be useful, because of the fact that we have overarching threats. We have an entire enterprise architecture landscape to work off of. I just haven't found sort of that easily understandable application of it. But I definitely think it's there. It's just, for me, patterns was just illuminating of like, oh, that makes sense. That makes it more efficient, makes it more traceable. Enterprise architecture in general is still a bit, complex sometimes. I think it's there. It's just going to take a little bit more time to really figure out how that works in a clear way.
Super, thank you very much, Rose.
Thank you.